Sweet. Okay. All right. I'm going to get started here. We got some people still rolling in, but I think it's good that we can get started here because I got a lot to kind of get through here. So we're going to talk about on-machine probing, CAM-based on-machine probing. Okay. And as we start to go through these, I'm going to kind of quickly introduce the team. So I work for technology application team. I sit in Elk Grove in Illinois, and I work for Chris Pollock. And we have kind of a small team, but really what our goal here is just to kind of showcase Sinumeric technology. So I sit in the decks in Elk Grove. Chris sits in New York, as well as Brian Baumgartner too as well. So we're a team of 3, but we handle a lot of the technology things for Sinumeric. What I'd like to kind of do is kind of talk about some of the resources that we have, kind of going through our some of the programs that we run, some of the things that we do throughout our day-to-day tasks, as well as some of the initiatives that we have that a part of our team. So one of the big ones that we do is we do training, and we have videos, and we have a nice website that you can find all this information on, and it is ussiemens.com/CNC for you, as well as you guys found this CNC webinars too as well, where you can actually sign up for the webinar that you're in right now. So one of the big things that I handle as far as one of my initiatives would be online training and training in general for our team. So we run training every month. It is free to the customer, complimentary, and we give on various topics between G-code programming to conversational programming to 5-axis programming in person. So we have definitely a lot of training that we can give. Another one, like I just mentioned, we have 2 in-person classes. One is a service class, and the other one is a level 3 5-axis class in high-speed machining. So we kind of go through the whole topic of 5-axis. We have what's in Elk Grove Village, where we have a 5-axis machine there, as well as computers to kind of go through a digital twin of a 5-axis machine. So we go that step by step by step, and that kind of gives us a good understanding of what is Sinumeric 5-axis. Next thing is, and which I'm really grateful to be a part of and help manage, is the YouTube channel. So we have a lot of content on Mr. CNC. So if you have a question, can people not hear me? I'm coming through the chat and people say they cannot hear me. Can everyone hear me? Sound okay? Okay, other people can. Good. Okay, good. Good. Thank you for the people in the chat. So the YouTube channel, like I said before, has a lot of content on it. If you have not gone there and click subscribe and like some of the videos on there, I suggest just stopping by and looking at it, take a look at it. If you find something interesting in it, hit that subscribe button and subscribe. We are slowly approaching almost 1 million views on this page, so it's a big deal. We're about 50,000 away from hitting that million, so we are slowly approaching that 1 million views. So it's a big milestone. So I have some people that say they can't hear me and some people that say they can. All right, everyone's giving me a thumbs up that they can hear me. Okay, good. But with the YouTube channel, I just want to stress that if you have a question, there's this little search button here. Definitely a good research to come here and kind of search one of the topics that you're looking at. If you have a question or have something that you are like, I want to learn about probing, or I want to learn about this, just come in here and type that key phrase in there under videos. Something's going to pop up, and you're going to be able to definitely find that out. Chris has done a lot of videos, and some of the classes that we've given over the years, I think it is a lot of information. Perfect. So one of the things we started a couple years ago, almost 4 years ago, is something called the VPE. It's an initiative that Brian Baumgartner on our team holds up. And basically, if you go to our website and you click on the VPE link and you enter your information in, there's going to be a little question box. And what the goal of this is to kind of see what your question is and then get you the right expert inside Siemens. A lot of this is designed for program and operation, but we've seen kind of a lot of different things come through this program. But it's kind of really nice to kind of get in front of someone that works at Siemens to be like, okay, this is definitely an NX question, or this is definitely a commissioning question. This is definitely something that needs to go to the AEs or maybe field service. So this is definitely a really good resource. If you have a question, I know that each one of us on our team take time out. We each want to take one of the cases that may come in. Maybe Brian might answer it, Chris might answer it, or maybe we might need to pull in engineering. So each one of us take a task to do these VPEs. So it's definitely good. So here it is on the website, right underneath training classes is virtual product expert. Lastly, something I really want to kind of get into before we get into the real meat of this webinar is we have no secrets at Siemens. We like to put all our documentation online. Here is the website for that. You can go and type in measuring cycles and pull up the manual for each one of our Sinumeric cycles right there and download it, and even versions too as well. So if you have an older control, you can definitely go and download that old manual. It's something that I really like to kind of stress, and I always like to tell in our webinars and every one of the online classes and the classes that I teach is really stressing this, because this is a big thing. Because if you don't know something, you can always pick up a book and learn and read. So this is definitely a big thing for us, that every manual's on there. But we're going to get right into it. What is on-machine, CAM-based on-machine probing? Well, in the industry today, there are a lot of different things that are coming in and a lot of new technologies that are coming into play. And one of them is the probe, right? But we have to kind of look back and take a step back and find out what is going on. What do we need, and what is the reason, and how can we take advantage of the probe, right? One of the thing is, definitely skills. There's definitely a skills gap. Some of the parts that we're doing now have tighter tolerances. We want to be able to automate, not just with a robot. When we hear automation, we always think that it has to be a robot. The nice thing about Sinumeric is our controls built to automate with simple things like sister tools and probing and the cycles that we have on there as we get in through today. Process control. After the part is machined, how do we check it? What is the process? And we need it faster. These are the things that come into play that we need to keep on thinking about. So this is where we need to be flexible and we need to keep moving forward. And how do we do that? We got to get some tools that are on the machine already and utilize it in our CAM system in an easier process. We don't have to have this go out of the shop floor, probe, go back to CAM, and this kind of big loop that we get stuck in. So we can just stay in CAM, figure out kind of our strategy, and then move right to the shop floor and hit cycle start. So the right measurement is important, right? We need to make sure that we need to make the right part, and we need to measure, validate, and compensate if needed, right? So the definitely key is to make sure that we have the right strategy moving forward, and then we get the shortest cycle time. The name of the game for throughput is shortest cycle time, and that's not always meaning cut time. Most of the time we talk about cycle time, we're talking about real machining, but at the end of the day, it's the overall process, like we talked about with measuring and process control after it, and when it leaves the machine, and when we program it. How quickly can we program it? How quickly can we set it up? And how quickly can we machine it? How quickly can we measure it? Reducing that cycle time is really kind of the name of the game. And that's what you can either lower your costs or take it as profit. So this is the name of the game. The more parts that you can put through a machine tool, the more you're going to be able to lower your costs, and throughput's going to go up. So CAM-based solutions. So I work for Sinumeric and I work for the control side, but there are a lot of CAM products that are on the screen. And the reason why I'm showing that is there's a lot of CAM systems out there that have different probing packages and probing options. The reason what I've chosen the ones that are on the screen, those are the ones that have our cycles and being able to use the Sinumeric cycles. So when you're using a Siemens control and a Sinumeric control, like an 840D, an 828, or now the Sinumeric one, these are the CAM packages and the probing packages that have our cycles. So then that's the nice thing. So if you want to stay at your desk and you want to utilize probing cycles, these are the guys that have them, and you're going to be able to utilize that as you move forward. So what we're going to talk about today is using Siemens NX with probing. So we're going to really kind of dive deep and use that CAM package as a tool to kind of stay in one system, look at how we're going to set our work offset up, machine some features on a part, and then measure those features. So then we can either update a tool if we wanted to update a tool, we can, save it and write it out to a text file. Once we measure it with one of our cycles, now we can do whatever we want with it. So the overview. So what is on-machine probing? So on-machine probing is taking the CAM-based probe and a cycle that's on the control and outputting the exact same thing. So when I post the program, we're actually going to see the same mask that we see on the control. It's going to be a 1-to-1. So the parameters that are on in the CAM system are going to match the parameters that are on the machine tool, and we're going to have that 1-to-1 feel. The nice thing about that is there's no second guessing. You go right there, you have it in your CAM system, you're able to simulate it in the CAM system, you know what you're going to get when you post, go right to the machine, cycle start. And I got to be honest with you, when I first did this and downloaded it and put it in my kit, I just want to see how many clicks it would take and if I had to change anything. And it was amazing. I just basically click post and hit cycle start on the machine tool, and it worked beautifully. There were little things that I needed to kind of know to start, and I'm going to tell you that from the Sinumeric side. So on machine probing cycles, the nice thing is of all the CAM solutions that I showed in the previous slide, the nice thing is our solution, Siemens NX solution on machine probing, has all the Sinumeric cycles. So that's the nice thing. So it has all our cycles. It is using all their cycles. So it's really, really nice. It has definitely working on Renishaw and Bloom. I know that's the thing that NX is starting to work on. Bloom cycles for milling, you have workpiece measurement, you have work offset compensation, tool data offset, and then tool setter, measurement of the tool length and diameter, and then broken tool edge and profile check. So these are the nice things that those can do as well. So on machine probing. So one of the things is our control definitely can handle a star probe. It can handle a surface check. It can handle an L probe. These are the things that SINUMERIK can definitely house. What's in works is the support of that inside CAM. So that's the thing where this is where on-machine probing inside NX is starting to work towards. And it is not supported at this current time inside NX, but definitely supported on our control. You definitely can utilize a star probe, an L probe. Definitely the option is a surface checking too as well. I've definitely done that too. It's quite a cool process to do that on our control. So these are some of the things that some third-party probing companies have started to implement as options, and definitely can put that on our control and start utilizing it. So each one of the pictures that you see, I have done on our control, and it's quite nice to be able to measure some of these things. So great thing. Just in the CAM system, starting to work. And because we have an open architect in NX, we have the ability to start working towards that if choose need be. So, as I said, really there's this whole process to making a good part, right? We need to have the tool control and make sure the tool is measured correctly. We need to make sure the workpiece is set correctly. And then also too, we need to understand what our part looks like before we actually take it off the machine. So these are all these kind of things to kind of make sure that we're not going to remachine or have to remachine or take it off the machine, put it to a CMM, bring it back to the machine if we're off a little bit. And that's kind of the name of the game and what we've had on Sinumerik. And one of the things is now we have the ability of putting that in CAM and kind of saying, this is how we're going to machine this part. This is how we're going to check that part. So this is really, really nice. So some of the use cases, right? So why would we need this and why would we need to do this? Well, as you can see in this video here, we have kind of a complex fixture here, right? And if we were going to go to the control and measure this, we would have to figure out how to do this with this fixture, and we'd have to move the machine around manually. But the nice thing inside CAM is we know where all this is because we have it in CAM and we have it modeled up already. We can start to utilize Pro and be like, we want to take these points. So is the part located and loaded okay? Is the part where it's supposed to be? Has it shifted? Has the fixture shifted? Is the fixture aligned? So these are all things that we can answer with on-machine probing. Another use case, right, is the material that we picked, like a casting, where the material is supposed to be. Do we need to adapt the machining process because the material is not where it's supposed to be? Or do we need to align the machine or program? So we need to align the machine because we have a casting that is changing ever so slightly. Finding fixture offsets, that's really nice. So we can definitely find our work offsets. We can definitely pick up where simple fixtures are and validate part location, then also have error checking. So these are all really nice things that we can do with on-machine probing. Tool offsets. I've already kind of did a couple videos on this, and it's on our YouTube already about doing measure, cut, measure, and looking at that. This is where the rubber hits the road. Where we can actually check the part with probing and then update our tools. That's really the name of the game. And then we can do measure, cut, measure. So I'll show you how I would think about that as I start to utilize this inside NX. Another big thing is we talked about everything, setting the work off step up, making sure the part's okay, making sure the part's loaded okay. But then the last thing is understanding, like, what is the size, right? Some data collection, and then also adapting your process. And that's what I just talked about would be measure, cut, measure. So we definitely have a lot that we can do with this. And I'm really kind of excited because this is what I think a lot of people really want to utilize probe for is something called measure measure. So I did it where I just did it on the machine using our cycles, but this is where we're actually going to do it inside NX. So another thing too is utilizing on-machine probing to start to measure our tools and have those cycles to be recognized and do tool breakage and tool wear. So this is a nice thing to have if we start seeing discrepancies. And then this is where Sinumeric kind of comes into play from the automation standpoint, where we can utilize on-machine probing and check if the tool's broken, right? If we know a tool comes out 10 times and on that 11th time she's starting to really wear, then we can really kind of check that, scan for that. And if it is that case, then we can pull out a sister tool and it really becomes quite easy. So this is another thing where we can know, like, if we're cutting Inconel or we're cutting stainless or we're cutting tie, and we know that we get 18 minutes per edge or we get 10 minutes per tool or we get 10 times per tool, then we can start to use tool management on the Sinumerik in conjunction with on-machine probing to be checking our probe at what operation that we know we're gonna see those wear cases. So some of the cycles, right? So right now we have availability, like I said, all our cycles. We have Renishaw cycles and the Bloom cycles on there that we definitely are showcasing in 2412. So what are the cycles? What is on-machine probing? So as you can see here, this is the cycles that we're utilizing as we start to use the operation inside NX. So we can do single point, circular, pockets, spigots, rectangles, a line and edge or line of plane, groove, rib, corner, or in segment of a corner or in or out of the corner. But the nice thing is you have all these cycles, right? And the nice thing is really easily within a couple clicks, they're all in one. It's one operation. It's one thing. We don't have to decide we want a pocket or we want a rib or we want a groove or we want a line edge. It's all in one operation. We pick what we want inside NX and then we just hit generate. And it's really easy. So that's the nice thing. And as I can say, as someone, not knowing anything about this on-machine probing inside NX, but having done things in NX like this has been the cleanest, quickest way to getting probing out of a CAM system that I've seen. So how's it work? Basically, pick the feature that you want, select the feature, and hit generate. It's really that easy. So how does it work in programming in NX? We can kind of see that. We call up the operation template, we assign the geometry, and then we select from the list of cycles, right? So how does it work? So we can kind of see here, we go to create an operation, we go to probing, and we start to select on machine probing, right? And then we go either to program. These are the programs designated in the program view, and we're going to pick a probe, and then we're going to pick what work offset we're going to choose, and then the method, right? And here, this is the dialog, right? We just picked the geometry right now. So we're going to pick a surface, we're going to pick an edge, right? And once we pick that edge, it's going to decide what cycles you think you could be using, right? So this one is going to pick up either an edge, a line edge, or a line of plane. So these are the different cycles that you can definitely choose from. So again, that would be just one edge. So now if we pick another edge, right, we're going to pick the other side of it, right? Now it's going to say, do you want to pick a rib, right? We want to do an edge distance and decide where our center is going to be from the edge distance. So it really becomes quite intuitive, right? So as I'm going to jump over now and do this in NX, right? So I have my part, right? And I have this part. And just a simple kind of part with a bunch of holes in it, right? But I just wanted to keep it super simple. And really, the name of the game is whenever you're thinking about this, we really talk about really just the machining when it comes to CAM, right? We're going to say, how are we going to machine all these holes, right? And that's really kind of what we do here, right? However, what needs to happen is we need to figure out on the machine where this is, where our work offset is, G54, before we go to the machine, right? So we've done the machining. The nice thing is now, if we really wanted to, we know what our material is going to be, right? If we have our material, right? So here's our material. And we can basically now set our work offset. So we can come in and do 2-point edge alignment, right? So we can come around and do a 2-point edge alignment. So how does it work, right? So if I wanted to, if I come in here, all I did is I went and created an on-machine probing operation. And once it goes into it, it pulls up. I had the edge distance. All I did is I picked this surface, right? And if I go in this dialog box, if I now get rid of that and I say this one, right? And I say, okay, it's going to do the edge alignment that for this side of it versus the y negative, it's going to go to the y plus, right? So I say I want to do an edge align. I hit generate and hit OK. And now we have just aligned an edge. You see the dialog box now? Oh, that's right. You don't see it. It's so weird. It's so weird. I have the dialog box up. Is it frozen? I'm sharing the whole screen. Let's reshare. How about now? There we go. How about now? Everyone good? And you see the dialog box? Okay, good. So I picked edge distance here, and we can see now we're going to do an edge alignment, right? And inside the probing parameters, we get to choose. We get to choose now, do we want to set work offset? And then we want to maybe change, instead of the active work offset, right? We want G54. Okay. And, here, we definitely want the first point and the second point. Now, you don't have to do this. I'm just choosing it because I went into the dialog box. It wants me to tell you how high we want to actually hit those points, right? So now I've hit the 2-point alignment, and definitely now I can align my part, right? So once I align my part, then I probably want to pick up my Z, right? So I know where my top of my part's going to be, the top of my work plane. And then I'm going to do basically find the center of the part, right? So this is all great. We're probing our part. Now, the one thing that missing on here, and what's the big caveat, I would say, of NX and everything that goes on here, is this is just looking at probing our part, right? One of the big things that you get when you start to think about this is if you do have a machine kit, right? We start to know that there's some type of measurement from the home position of our machine to that block, and that's what gets put in our work offset, right? So the thing that's nice about NX is if you've built your machine inside NX to represent what it's on the floor, right? This home position and the top of your block is the same, and the travels of this machine represent what travels on your machine are, and your kit is built in that manner, you can use NX to write the work offset to where it would be in your CAM system. So basically, once you go to the machine, you don't even have to set this up for the very first time. You literally can just hit cycle start. And what I've done is I've done that. One of the things is I did this in this section, in this mill control under notes, I wrote to G54 from my part program. So when I go to run it, right, I go and I write these values in my work offset. Then the nice thing is, I can then update my work offset and then basically go in machine. So it really makes life a lot easier, right? I can show you that. So as I post that out, I bring it over to the real machine, and this is my virtual machine. And this is the same machine that's sitting in Elk Grove Village, right? And we have the ability now to measure. So I have set my work offset. And basically, as you can see, my first line is going to write this to G54, right? Then I'm going to come in and call the probe out. And when I call the probe out, I'm going to go in and do my 2-point alignment. Here's my 2-point alignment. I'm going to set G54, right? And I'm going to actually see it update my coordinate rotation, right? Once I'm done with that, I reposition and I come and take my Z hit. And then I reposition again. And then I do my 4 touches around the outside. So as I reset my workpiece, right? And I can come in and go to my work offset, right? And here's G54 as we see here. We got some different values here, as well as we have a little bit of rotation in our Z, right? So we have a little rotation in our Z. So we're going to clear that, right? So now we have 0, 0, 0. And when I go back to my program and I execute this and I hit cycle start, we'll actually start to see it put values in. So we know that We had nothing in there before, right? Now, as we start to touch things, we start to see these changes, right? We see Z had a little bit of change, and now we might see X and Y have a little bit of change. Keep in mind, this is the same replica that is on inside NX, so we might not see too much, but we're seeing a little bit of movement in Z, and we should see that. I don't know if I got the X and Y going to fine or not. We'll see. So I didn't. I went to geometry. But as you can see, the Z touch went to fine. It wrote it here in fine, as well as we have a rotation from our 2-hit going into Z. This is the nice thing is there was no work offset here, just like there would be no work offset on your machine tool when you go down there. And from NX, you have the ability to write out your work offset to G54, G55, whatever one you choose, and then start to measure right away. And it was just post and go. This is the nice thing about that. Then we can go ahead and machine, right? We can go and machine our part. So we can start to machine our holes, right? I'm probably going to just do the first hole and the second hole so we can show measuring like it is in the CAM system. And if you guys are thinking of some questions, I would say as this starts the machine, go ahead and start throwing them in the chat or in the question section. I prefer the chat because it's a little bit easy. A couple of are coming in, I can answer them. Yes, this is being recorded. The recording is going to be put on YouTube afterwards, as well as you will get an email when this is done that the recording is available. So once this one's done, I'm stopping. I'm not gonna do all the holes. So I want to showcase the measuring. But if we go back to NX as that's finishing, right? We turn off the machine. We can go back to measuring now, and again we can measure the hole. So here we're gonna actually measure the top hole. And what I've done, again, because of Sinumeric, I know some things. I know that OVR4, right, is the measurement of the cycle. So I wrote OVR4 to a variable so we can check and see what the size is. It's supposed to be 60 millimeters. We'll see if it's 60 millimeters, right? So we're almost there on our last one. Okay, we can reset, go to jog, and we'll definitely send this home. All right, so we did a few of the holes, but we go into measurement now, right? And now we have the ability to execute this where we're going to go and now we're going to measure what it is. And one thing that's nice is if you ever hover over, right, one of our cycles and go to help, you get pretty much what the cycle entails, right? But at the bottom, this is what I like to show most customers. If you go to result parameters, it tells you where all this data is going, right? So we have OVR4 is the hole diameter, right? So I wrote R10 to OVR4, right? And as if I execute this and run it, it's going to grab the probe and it's going to now probe those holes. And now we have definitely the data. The nice thing is in our cycle, we can do a couple different things as well. We can do it inside NX, but we can either measure, right, and then do math outside if we wanted to, or inside the cycle itself, right, we can either update tools, update a work offset, right? So we have a couple different things. We can update a work offset, we can update a tool offset, right? Or we can update a sister tool if we wanted to. I just chose to measure, right? Now, if I want to go check that R parameter, I can go to R parameters. Look, I definitely am way out. So this would be one of those cases that I probably should be adjusting my tool a lot, right? One of the things of why in this real world I'm so far off A couple different things. I definitely did this on purpose to show that we are measuring quite big because I am utilizing a roughing tool with roughing inserts. With roughing inserts, as well as I'm using the real geometry of the tool. So if anyone saw that quickly, if I call that tool back in, it has the grooves in it just like it would, and the chip breaker like it would in real life. So that's kind of what we can see from the 3D model. So if I go to machine and jog and I call that tool back up, you can see that we have the real flute geometry of it, and we're seeing that kind of come into play as how much we're pushing the tool and the scallop. So we're definitely overshooting a little bit because I was going really, really fast, the machine as fast as I possibly can. But as you can see, we are doing that measurement afterwards. Now, the nice thing is as you can kind of see, we definitely probably want to have some type of control. So we can even add to our mill control of like an if then statement, right? If we wanted to reach to 60 millimeters and we started out slow, right? Where we started out having, we know that we're overshooting because we're going too fast, or we need to slow down. But the nice thing is you can start to add that logic inside NX and definitely have a measure cut measure definitely right here really, really quickly and not have to kind of do this all in the control and on the shop floor. It's all kind of then carries with this part. So we can start measuring features all around our part if we wanted to by just going around and start clicking it if we did another one. So we can hide our work material and go right into on machine probing, right? So we pick on machine probing, right? And now we go right into picking our geometry, right? And we pick the side hole, right? And it's going to give us an option of what we want to do. So we want to measure the hole, right? Description measure the hole. So we're going to measure it and we hit generate. Say okay. And if I go now and I post this, let's say side, right? Oh, I guess I didn't hit generate. Come on. I have to specify the vector of where I'm probing, right? Let's see if that gives us some path here. Nope. I guess I didn't hit OK again. Any questions coming through? I have looked at the chat. I have not seen anything come through the chat. The questions side, still no questions. Got a question coming through. It says, will NX set up the measurement report? And does feed rate affect probing? My machine doesn't have a Renaissance probe. Doesn't have Renaissance probes. Does that matter? It doesn't matter what probe you have as long as you do have a probe. Feed rate shouldn't matter depending on the builder and how it set it up. There should be should have definitely the the right the right feed when you are probing, but depending on the builder, if they didn't lock out the feed rate, that could have an effect when if it differs from the calibration feed rate. This is what version is this available in? So the lowest version that this is available in is 2312 8000 build. So that would be definitely the smallest, the lowest one. I'm in 2312 as we speak right now. So that's going to be the lowest one. So that's definitely good. If you want to keep coming the questions in as I was waiting for everything to kind of load up, we'll go back to our PowerPoint presentation here, right? Oh, why did I lose this? Here we go. I'll have to look into the Cycle 150. I have not looked at that closely, right? I have not looked at that closely. If we go back to the cycles, I can look and see if it has that cycle being output. But yeah, that definitely would be a good question. So I'll double back on that when we finish the presentation. So one of the things we talked about kind of with NX is we wanted to validate this sitting at our machine tool. So I had my not sitting at our machine tool. So I'm sitting on my PC right now and I validated that on a digital twin, my GME50 that's sitting in Elk Grove. What if you don't have my virtual machine? You'd have to go out to the machine and verify it. So the nice thing is there's a couple different ways that you can kind of utilize this. You can utilize VNCK inside of NX. You can use my virtual machine inside NX, or you can use my virtual machine as a digital twin. The reason being is that's going to give you the most precise simulation of what's actually going, because it's actually going to simulate the cycle and the movements of the cycle. That's really kind of the key. The nice thing with this being built inside NX and us helping with NX side of things, the CSE, the simulation base of this without VNCK or my virtual machine, is pretty close to what's actually being simulated on the control itself. This kind of be able to definitely help with simulating the one-to-one would be the VNCK in my virtual machine. And one of the things that we just did is we just kind of went through how you set up a work offset with on-machine programming. We program 2 points, then we program our Z, then we program X and Y. So it's kind of really kind of showcasing where we're going to rotate around. If we really wanted to get even more crazy, probably don't need it in a block kind of material where you're going to machine something from a block, but you could totally do a 3-point alignment too as well with a line plane with our cycle. So we got line plane, line edge, and then we can do Z and then X and Y. So here's another example on a real machine. We're going and doing a line plane. So here we're now picking up X and Y now. So when we're done with that, now we're good to go. Aligning a tool offset during machining. We definitely want to look at this pocket and see how big the pocket is. We're definitely going to measure that pocket. We're going to measure the width of the pocket and then update our tool. And then we basically have an inspection of those dimensions, right? So as we can see here, we're going to measure, cut, right? Come to our pocket in the middle, and then we're going to come in, hit the Z, make sure we hit our depth of our pocket, and now we're going to actually look and see how we're going to actually cut. Then we're going to measure, cut, measure here, and this is how it's actually happening on the machine. So where to find this at, right? Right now, if you have a seat of NX, you can go and find this on Post Hub. You can find it under the support resources, and then you can download on machine programming for the version that you have, right? So that's the nice thing that it is definitely able to be downloaded on the web on Post Hub, right? And this is something that you can download, but definitely needs the support to be putting into some of your kits, right? But it's definitely on Post Hub right now, right? On machine probing. And a couple of questions kind of came through. One of the things is you definitely need to have a certain license for this, right? So a couple different licenses that you're going to actually need to do this. So you have a um, 305, 79, and then 78, and then you definitely need the package point to do if you want Sinumeric cycles. You definitely need the package too. So these are a couple different ones. So if you are interested in on-machine probing, definitely talk to your reseller, whoever's supporting you from NX side of things, to find out what licenses you need. But these are the ones you need to actually execute on-machine probing. But it's definitely a really nice feature. I'm frozen. There we go. All right, questions, right? So the questions are starting to come in. We got a couple different ones, right? So I'm going to double back with the Cycle 150. I'll definitely talk about that one. It says one of the questions we got that came in through the chat says, is the measure cut measure strategy, will it output the logic to recut the feature in the measure out of the spec? This is something that you would have to do inside of NX. So this would be something you'd have to do inside of it. It can output it, but there's no cycle right now for measure cut measure. Meaning that if we looked at NX and we said, okay, if we looked at NX in our measure cut measure in this scenario, right? If we said we wanted to kind of redo measurement, we would have to then bring this and then put it down here and do a recut. So then this measure cut measure would then be measure cut measure versus just measure. So that would be how that would work. So this is the best practice to use mill control, or is it sometimes warranted to customize the post to handle the example of the work outside on the own? It's kind of you can do it in the post. The problem that I see here, and the nice thing about mill control is that it definitely has a spot, right? So this is this spot versus if I just posted it on this very first one. And then if I wanted to, I could totally get rid of this, and it's just what I kind of know that it's a nice way to kind of see what I'm doing, right? It says, does offsets insert manually? Do the offsets insert manually? Can someone, if you want to elaborate on the insert manually offsets? So I had another question come through about the licensing. Again, on-machine probing inside NX is a licensed thing. You can download it on Post Hub, but you would definitely need the licensing, or make sure that you have the licensing to utilize it inside your kit or on NX in NX. Oh, we have some other questions coming in. Let's see. Says, have I used Mastercam to do this process? I have not. So this is something that's not in my wheelhouse. I don't know if they've done something like this. I seen another one again, the Cycle 150. I definitely will look again at that too as well. Looking to see if that actually can be posted out. Let's look back at the chat. Says this is after the offset is inserted manually. Can it be obtained? So you're saying after we do the measurement of the probe offset, I have does the offsets insert manually? How G code is changed after the offset is obtained? So you're saying we come in and we probe, and then the offset gets updated, and then how does the G code change? I need a little more on the whoever GL is. I need a little bit more on the question so I can answer it. Question came in just about the overall webinar. When this is done, there'll be an email link sent out where you can watch this video, and then following the webinar, I will then download the video and put it on our YouTube channel as well. So we put all our webinars on our YouTube channel so you can watch it again. No. So the questions coming in, does it regenerate new code? It does not. We're not adapting the G code. That's the key here. So really the name of the game is when we look at NX is we're setting a work offset. This to me is really powerful because we just really want to be able to set a work offset right from the get-go from a CAM system. So we're doing 2 points, then we're touching your Z, and then we're doing 4 points. So we're just setting our work offset. So right off the bat, this is really what I think most people need. And then we're going to machine. So the code is getting posted out here. So this is just setting our work offset, and then we can then measure the features on the part and then decide what we want to do. Do we want to measure and cut, or we want to do anything like that? So this was not really, this is the intent of this webinar is not to show adapting the toolpath. So where you plug, the probing from the machine into this to generate new toolpath. And that would be kind of subjective to the application. Any other questions that we can kind of come up before we have a close? Yeah, so mill control. Mill control is one of those things that the question came in just to, can you show me some mill control things? So again, this is definitely driven from your post and making sure your post can do it. If you're using post configurator, this is something that's in post configurator to utilize. But under any, you got mill planer, here's mill control, and I think under mill contour, you also have mill control too as well. Either way, you can pick one of them, but as long as you pick mill control, there's a lot of different things. All this is just doing is, do you want to put a tool in the spindle? You want to call up a different work offset? Do you want to, what program it is? Maybe you're going to call off a tool offset. So there's a couple different things you can do in here. You can definitely do start events, turn the coolant on, right? So you can definitely use this as a bunch of different things. I personally use it, the note section, because I want to do different things here, right? So one of the things that I did on this first one is I wrote in the note section the writing of the work offset. So one thing that we didn't know when we went to the machine, well, on the virtual side of things, the digital twin, we didn't know where that part was sitting in space. We had 000 for our work offset, which on the DMU50 is top right. So that would be the spindle moving to the top right of the machine. Therefore, we need to tell it where that top of that part is in order to drive the probe to do probing, right? We don't know where this is yet until we tell it. So this is what this line did. So I just wrote it in the notes. The nice thing with notes is I can keep kind of just typing and not using just the insert command. So I can have all these lines of code, right? And all these kind of variables if I wanted and I could choose to. And then once I hit post, right? Once I hit post, now I'm going to see a bunch of these lines that I've basically put out. So here's all the lines, and it just was straight text coming out. So I utilize this on the Sinumeric side a lot because I want to do a couple different things. Maybe I might set some variables up. Maybe I might write some things to some variables that I know are on the control, right? So I might take all this and I might say, R10 plus R11. Oops, sorry. Plus R11, right? So I might start adding some macro programs in there. So that's something I just take advantage of that's in a tool inside NX. This one really is huge because I can start to write things like writing my work offset or writing my measure value to a variable so that I can utilize it somewhere else. Hopefully that answers your question about mill control. All right, we're coming to the top of the hour. I have a few more questions come in. Thank you for the ones that have come in already. Licensing, definitely those are going to be held up to the reseller and the person that supports you and NX. So my biggest thing is I just really wanted to get this showcase how you can use probing for Sinumeric. That's really what I wanted to show. I have done a couple measure cut measures. I wanted to kind of show simulation of probe in a cam and then being able to post that out right to a digital twin, test the syntax and the posts right here. And I haven't left my desk. Now I know that I can go and hit cycle start on all this whole programs. And I'm definitely going to get my work offset done. I'm going to probe my part. I'm going to machine my part and then I can measure it right here in NX. And I went to the machine and hit cycle start. All right. Well, if no one has any questions, we're coming to a close here on this webinar, and I appreciate everyone's today. If you wanted to get a hold of me, my name is Dan Struble. I'm the Technical Application Center Manager in Elk Grove, my phone number, as well as my email. So I appreciate everyone coming to the webinar, and I look forward to talking to anyone further. And then check out for that link that gets sent out so you can watch this again if you wanted to, if you missed it, as well as check out Mr. CNC when this goes up on Mr. CNC as well. Thank you.